Welcome, pre-cal students, to part 2 of the review sheet. I want you to know there'll be a little bit of noise in the background as we're putting some dishes away and stuff, so there'll be a little bit of clanging, but you guys can handle that, and hopefully you should be able to hear me pretty plain. We're picking up here with number 37. Again, this is part 2 on the review sheet. And so let's go ahead and get started. In number 37, we are asked to expand this. Now, unless you want to write out that parentheses 7 times and do a whole lot of multiplying, there's definitely a much better way to do this. And of course, we're going to use Pascal's Triangle, and we are going to need, I believe, 8 rows. And I can do this pretty quickly, and so can you. This is not something that's difficult whatsoever. And once you write it down, you have the triangle. And number 2, I have no problem with you already having this done, written on a sheet of paper for a test. There is no need for you to do this every time, okay? So I have no problem with that. Now, this is the row that we're going to use. By now, you should know how to write Pascal's triangle. Notice we're taking m plus n to the 7th power, okay? So we want to use the row that has 8 terms. It's always 1 more than your exponent. So I have a power of 7. We need 8 terms. 7 plus 1 is 8. And this row right here has 8 terms, or 8 coefficients. So I know that's the right row to use. So let's go ahead and grab this row, and let's pull it out of here off to the side so we have it. And let's get rid of the rest of these numbers. So here are my coefficients I'm going to use. That was easy. Now let's continue on. Remember, m plus n, if you want to put a for m and b for n, you can. But as long as it's just a letter and a letter with no coefficient and no powers, and as long as the sign is plus, there's really no need to do any substitution. We're just going to say our first term has a coefficient of 1 and then m to the 7th power. Cross off your 1. Next is a 7. So a positive 7. Then remember, with the m, we go down 1. And then we put n to the 1 power. You do not need to put that 1 if you don't want to. I just wanted you to see that. Cross off your 7. And then plus 21. The m goes from a 6 to a 5. And the n goes to a 2. Notice how my total exponents was 7, my total exponents was 7, and my total exponents added up to 7. That will continue to happen because of this 7 right here. Okay, cross off your 21. My next term is 35. So 35. Here I had m to the 5th. So next I will put m to the 4th and then n to the 3rd. And then my next coefficient is 35. I better start writing a little smaller here. 35. I go from m to the 4th to m to the 3rd and then n to the 4th. And then my next coefficient is 21. M squared n to the 5th, and my next coefficient is 7, m to the 1, n to the 6th, and then my last coefficient is 1, n to the 7th. You do not need to put these 2 1s here that I just circled. You can if you want to. Either way is fine. So there we go. We did it. We expanded m plus n to the 7th power. It's called binomial expansion very quickly. It's very easy to do. Now I'm going to do something here real quick if you'll give me a second. I'm going to go backwards and get Pascal's triangle up here again. That's going to be very helpful to have for the rest of the problems. I don't feel like writing that out every time, and I should have remembered to do that, and I apologize. I want to cut and paste it so that we have that. Okay, there we go. So let me do that quickly, and then we will continue on with the next problem. Okay, there we go. All right, let's move on to number 38. Okay, now we're going to need to do some substitutions, okay? First of all, let's find out what our coefficients would be. We are going to the 5th power. We're raising x minus the square root of 2 to the 5th power. And so that means we want to have a row, 5 plus 1 is 6, a row that has 6 terms. And it would be that row right there. And so let's cut that row out of there so we have those coefficients. And let's pull it off to the side. And let's get rid of the rest of these numbers. So we found our coefficients. When you're expanding something to the 6th power, or the 5th power, excuse me, these will be your coefficients. Now, let's next make some substitutions. We're going to say that we have a equals x and b equals negative square root of 2. So since I made those substitutions, I can now call this a plus b to the 5th power. So I'm very quickly going to write out my answer using a plus b, and then once I have that answer, I will use back substitution, and I will substitute these back into the expression, and then we'll go from there and see what our final answer is. So here we go. Our first coefficient is 1, so we have 1 a to the 5th. My next coefficient is 5, so plus 5 a to the 4th, b to the 1 power. My next coefficient is 10, so plus 10 a to the 3rd, b squared. My next coefficient is 10 plus 10 a squared b to the 3rd plus my next coefficient is 5 a to the 1 b to the 4th, and then plus my last coefficient is 1 b to the 5th. Okay, now let's make sure all of our exponents add up to 5. 4 plus 1, 3 plus 2, 2 and 3, 1, 4 and 5, they do, so we're good there. And now we're going to make some substitutions. For example, I'm going to do all my substituting right here, and then I'll erase it every time. A to the 5th, for a I substitute a x, so I have x to the 5th power. Where a is, I put an x because a equals x, and x to the 5th power is just x to the 5th power. So there's the first term in my final answer. Now let's go on to the next term. I have this expression right here, and slide it down here very quickly, and now let's make our substitutions. So where the a is, I'm going to put an x, and where the b is, I'm going to put negative square root of 2 to the 1 power. Now let's be very careful here, okay? First of all, I have a positive 5 times a positive x to the 4th times a negative square root of 2. Well, a positive times a positive is positive times a negative is negative, so I have a negative. And 5 times the square root of 2 is just 5 square root of 2. And then you bring down your x to the 4th power. Okay? Back that up and watch it again if you need to, okay? But that is how you would simplify that term. Okay, let's go on to the next term now. And that term is right here. Let's go ahead and bring this term down, and let's make some substitutions. So I'm going to have a positive 10, and then an x to the 3rd power, and then a negative square root of 2 raised to the 2nd power. I really should do my powers first. I'm going to bring down my 10. X to the 3rd power would be x cubed. Now be careful here. A negative square root of 2 times a negative square root of 2 is a positive square root of 2. Positive square root of 2. And then excuse me, it's a positive, and then square root of 2 times square root of 2 is just 2. So you get a positive 2. Now I put parentheses there because if you didn't put those two parentheses, look at what you would have. It would look like you had 10x cubed plus 2. And we know that's not true. We know it's 10 times this x cubed times this negative square root of 2 to the 2nd power, and so the parentheses there reminds me it's all being multiplied. So if you take negative square root of 2 times negative square root of 2, you get a positive 2. Now 10 times x cubed times 2 would be positive 20x cubed. And we are moving on. Let's take a look now. Let me get a quick drink of water here, and let's look at our next term. Okay, here we go. Where the 10 is, I will leave a 10. Where the a is, I will put an x. And where the b is, I will put negative square root of 2 to the 3rd power. Now quickly we can do the x squared. X times x is x squared. Now be careful on the negative square root of 2. You have negative square root of 2 times negative square root of 2 times negative square root of 2. Do you see that? Negative square root of 2 to the 3rd power. Well, negative times a negative is positive times a negative is negative. Square root of 2 times square root of 2 is 2, and 2 times square root of 2 is 2 square root of 2. So when you multiply negative square root of 2 times negative square root of 2 times negative square root of 2, you come up with negative 2 square root of 2. Back that up if you need to and watch it again, okay? So I have 10 times x squared times negative 2 square root of 3. Well, 10 times negative 2 is going to be a negative 20 square root of 3 x squared. Okay, and again, I hope that makes sense. If not, back it up and watch it again. Make sure you're getting this, okay? All right, let's go ahead and work with this term here. I have 5. For the a, I will put an x, and for the b, I will put negative square root of 2 to the 4th power. Now x to the 1 power, of course, is just x. Negative square root of 2 to the 4th power would be negative square root of 2 times negative square root of 2. I'm not trying to win the neat penmanship of the year award. You guys understand that. We're going for speed here. Times negative square root of 2. Well, negative square root of 2 times negative square root of 2 is a positive 2. Negative square root of 2 times negative square root of 2 is a positive 2. And 2 times 2 is 4. So this whole expression is 4. So I have 5 times x times 4, and that would be a 20x. All right, and let's go ahead and clear this off, and we're just about done. One more term, and we're finally finished. B to the 5th. Well, b, of course, is negative square root of 2, so I'm taking negative square root of 2 to the 5th power, and that would be, of course, negative square root of 2 times negative square root of 2 times negative square root of 2. I think we'll just do it that way and save some time, if that'll work, and it won't, so we'll just forget that idea. So we have negative square root of 2 5 times. And you probably don't need to see this, but I'm going to make sure that you really understand it. Okay? Well, negative square root of 2 times negative square root of 2 is positive 2. Negative square root of 2 times negative square root of 2 is positive 2. And then bring down your negative square root of 2. So a positive times a positive is positive. Positive times a negative is negative. 2 times 2 is 4. So 4 square root of 2. Now that took a little more time than the last problem, but it's still much faster than writing out x minus square root of 2 with 5 different sets of parentheses and multiplying it out. All right, number 39, let's expand this to the 4th power. Okay, to the 4th power. You know, I think I lost, unfortunately. Yeah, I did. I think I lost my Pascal's Triangle. So we'll go back here real quick. And we'll put it right here. All right, we're going to expand x squared minus 3y to the 4th power. That means I'm looking for a row that has 5 terms. And so here it is. This row right here has 5 terms. That's one more than 4. And so that's the row I'm going to cut out, and those will be my coefficients that I'm going to use. All right, so let's pull those off to the side. And let's get rid of all of this, and let's get rid of this. And we now have our coefficients. Now that we have our coefficients, let's go ahead and let's see if we need to make substitutions, and we do. We're going to say that a equals x squared, and we're going to say that b equals negative 3y. Having done that, I can now write a plus b to the 4th power in place of this. So this should be done pretty quickly. My first coefficient is 1, so I have 1a to the 4th plus my next coefficient is 4, so it would be 4a cubed b to the 1. My next coefficient is 6, so 6a squared b squared. My next coefficient is 4, so 4a to the 1, b to the 3rd, and then my last coefficient is 1, so 1b to the 4th. There we go. Really pretty simple. Now all I have to do is make my substitutions, and I'm done. Okay, so let's go ahead and do that quickly. My first term is a to the 4th, so where the a is, I'm going to substitute x to the 4th power. I'm sorry, x squared to the 4th power. So where the a is, I substituted x squared, and x squared to the 4th power is not x to the 6th, it's x to the 8th. Whenever you raise a power to a power, you multiply the exponents. Okay, so that one's pretty simple, and we are moving on to the next term. Okay, where the a is, I'm going to substitute x squared to the 3rd power, and then where the b is, I will put negative 3y to the 1 power. Now, if you raise x squared to the 3rd power, that's going to be x to the 6th power, and anything to the 1st power is just itself negative 3y. So what I have is 4 times x to the 6th times negative 3y. Well, 4 times negative 3 is going to be negative 12x to the 6th y. Okay, moving on to the next term. Where the a is, I'm going to substitute x squared. So x squared to the second power. And where b is, I will substitute negative 3y to the second power. Now let's start with our x here. X squared raised to the second power is x to the 4th. Now be careful here. I have negative 3 squared. So negative 3 times negative 3 would be a positive 9. And if I raise y to the second power, y times y is y squared. There we go. So 6 times positive 9 would be positive 54. And then x to the 4th y squared. Only 2 terms left, and then only one more of these types of problems where we're expanding all the way out, and we'll move on to some easier math. Okay, where the a is, I'm going to substitute x squared, of course that's to the 1 power, and then negative 3y raised to the 3rd power. Alright, let's first of all start with our x. X squared raised to the 1st power is just x squared. Negative 3y raised to the 3rd power, well that's negative 3 times negative 3 times negative 3 is negative 27, and y times y times y is y cubed. Now 4 times negative 27 would be negative 108, and then of course we would have x squared left over and y cubed, or y to the 3rd power. And I did 4 times 27 in my head. Let me check that real quick. 28 carry 2, yeah, 108. Okay, that's almost our last term. We have one left and we'll finally be done. B to the 4th. So where the b is, I'm going to substitute negative 3y, and I'm going to raise that to the 4th power. Well, negative 3 times negative 3 times negative 3 times negative 3 is a positive, and 3 times 3 times 3 times 3 is 81, and y to the 4th power is just simply y to the 4th power, y times y times y times y. And I'm going to grab a drink of water. My throat is really raspy, and that is number 39. So only one more expanding problem, and it's going to be a doozy, unfortunately. And then we'll be done. You know, I'm actually thinking about not even having this problem. We've done so many of these guys. I think I will start this, and you can skip it on your review sheet if you really think you have a handle on this, or you can go as far as I go. I'm not going to continue the whole thing. I'll do part of it, probably about half of it, and then by then you really should either know what you're doing, or maybe you don't, and I hope that you do, of course. So, okay, we need one more row in Pascal's triangle, so here it is, 1, 8, 28, 56, 70, 56, 28, 1. And how did I know I needed one more row? Because I'm raising this binomial to the 8th power, and if I have an 8th power where you add 1 to 8, that's 9, I need a row with 9 terms, and this row right here only had 8 terms, so I needed a row right here with 9 terms. Okay, and that's how I knew that. Alright, let's go ahead and see if we can't get rid of this big triangle here. And now here's the coefficients we're going to use. There we go. Next, we do need to make some substitutions. Actually, for a, we don't need to. That's just going to be totally acceptable. So maybe this problem won't be as bad as I thought. But for the 1 over a, we're going to say that b equals 1 over a. So maybe we will do the whole problem. We'll just see how it goes. So now that I've made my substitution over here, b equals 1 over a, I'm going to say a plus b to the 8th power. Okay, so real quick, I would have my first, I'm going to go right down the line here. My first coefficient is 8, my second is 1, my second coefficient is 8, my third is 28, right on down the line. So I would have a to the 8th plus 8, a to the 7th, b to the 1, plus 28, a to the 6th, b squared, plus 56, a to the 5th, b to the 3rd, plus 70, a to the 4th, b to the 4th, plus 56, and I think I forgot an 8 right here, didn't I? Yeah, I did. There we go. Squeeze an 8 in there, 28 and then 8, plus 56, a cubed, b to the 5th, plus 28, a squared, b to the 6th, plus 8, a to the 1st, b to the 7th, plus 1b to the 8th. Okay, so maybe this won't be too bad. There's no substitutions we're making for a, so my first term is a to the 8th, so I can totally be done with that term. Let's go on to the next term here. I already know that 8a is going to stay the same, so I bring down 8a to the 7th, and then b to the 1 is 1 over a to the 1 power, and of course you can put a to the 7th over 1 and 8 over 1. Okay, so your a would cancel once with your a to the 7. You have a to the 6th. So this isn't going to be too bad at all. 8 times a to the 6th times 1 all over 1 would be 8a to the 6th. All right, moving on to the next term. I think we'll finish this problem. Won't be too bad. All right, next I would have 28 over 1 a to the 6th over 1, and then in here I would have 1 over a squared. Now think about this. 1 over a squared. 1 times 1 is 1, so the 1's going to stay a 1. A times a is a squared, so it's going to be a squared. So basically what I have is 28 over 1 times a to the 6th over 1 times 1 over a squared, because 1 times 1 is 1 and a times a is a squared. Now cancel out your a squared here, take 2 a's away from here, a to the 4th. 1 times 1 is 1, so your denominator is 1. 28 times a to the 4th would be 28a to the 4th. Yeah, not near as bad as I thought, so this will not be too horrible. All right, moving on to the next term. The only thing I've got to worry about here is the b to the 3rd. So I have 1 over a for b to the 3rd power. So 1 times 1 times 1 is 1, and a times a times a is a to the 3rd. So I'd basically have 56 over 1 times a to the 5th over 1 times 1 over a to the 3rd. Cancel off 3 a's, take away 3 a's, you're left with a squared. Your denominator is 1, so you would end up with 56 times a squared, which is 56a squared. All right, moving on here. And we're going to make this even a little faster. I think I've done enough of these now for you to see. All that we're doing is putting 1 over a in for all of these. And your numerator is always going to be 1, because I don't care if you take 1 to the 4th power, 1 to the 5th power, 1 times 1 times 1 times 1 times 1 is 1, and a to the whatever power is going to be a to that power. So really I would have 70 over 1 times a to the 4th over 1 times 1 over a to the 4th, because 1 over a to the 4th power is 1 over a to the 4th. So your a's would cancel. Your denominator is 1, and 70 times 1 times 1 is 70, so plus 70. And moving on. Okay, next term, I would have 56 over 1 times a cubed over 1 times 1 over a to the 5th. Take away 3 a's from up here, take away 3 a's down here, and you're left with 56 over a squared. 56 over a squared. But we're going to bring our a squared to the top, so our answer would be positive 56 a to the negative 2. Okay, so we're going to bring that up top and change the sign of our exponent. Let me get a quick drink of water and we'll continue on. Okay, it looks like a negative sign there, but it's not. Let me get rid of this little negative sign here. All right, here we go. For this term here, I would have 28 over 1 times a squared over 1 times 1 over a to the 6th. Cancel 2 a's here, take away 2 a's down here, and you end up with 28 over a to the 4th. And of course, if it's 28 over a to the 4th, we're going to bring the a up top and make it a to the negative 4th. Easy enough. Moving on to the next term. This was not near as hard as I thought, so that's good. All right, for the next term here, I would have 8 over 1 times a over 1 times 1 over a to the 7th. To take away your 1a, take away 1a from here, and you end up with 8 over a to the 6th. 8 over a to the 6th, not sure what happened there. 8 over a to the 6th would be 8a to the negative 6. And then finally, we're almost done. Our last term, which would be b to the 8th, would simply be positive, I gotta be careful here, 1 over a to the 8th. And of course we're going to bring that a up, and so it would be 1a to the negative a, and you do not need that 1 right there. If you want to not write this 1. You don't have to have it. And if you want to put it there, you can put it there. Okay, totally up to you. So there we go. That's the answer to 40. And now from here on out, the review sheet's going to be pretty simple. So let's finish this up, and I think we'll be doing good. Okay, actually, sorry, I do get frustrated when I make mistakes. There is one more expansion problem, and I did forget about that, but we need to do this because of the I squared equaling -1. And no, I will not give you a lot of these on the test. I will be very reasonable. Sorry about my mistake. There's one more. Okay, a plus 5i to the 6th power. So we're looking for a row that has 7 terms, and it's this one right there. So we're going to cut out those coefficients, and we're going to move them somewhere. And let's slide this over for a second. And just that quickly, we have our coefficients. And by the way, don't forget, you're welcome to have Pascal's Triangle already written out. I have no problem with that at all. Now, let's see if we have to make some substitutions. Looks like we do. A is going to equal 1, and B is going to equal 5i. So with that in mind, I now have a plus b to the 6th power. So using my coefficients up here quickly, I would have 1a to the 6th plus 6 a to the 5th b to the 1 plus 15 a to the 4th b squared plus 20 a to the 3rd b to the 1 plus, no, that can't be right. Is that right? Let's see. Yeah, that's right. No, that is incorrect, and I apologize. This would be a 3 right here. There we go. And then we'd have a squared b to the 4th, and then we would have, and what would be in front of that? A 15. So I'm really making mistakes here. 15, there we go. And then plus 6 a to the 1 b to the 5th, and then plus 1 b to the 6th. Let me grab a quick drink here. And now let's continue on. Where there's an a, I'm going to substitute 1. So 1 to the 6th power is just 1. So there's my first term. That's pretty simple. And now moving on to my next term, I'm going to substitute a 1 for 5. And of course, 1 to the 5th power is just 1. 1 to any power is 1. So 6 times 1. And then for b, I'm going to put 5i to the 1 power. Anything to the 1 power is just itself. So 6 times 1 times 5 times I would be positive 30i. Okay, moving on to our next term here. 15, and then 1 for a. 1 to the 4th power is just 1. And then we would put 5i to the 2nd power. Now, if you square the 5, that gives you a 25. If you square the I, that gives you I squared. So we really have 15 times 1 times 25i squared, and 15 times 1 times 25 would be 375, and of course that's 15 times 1 times 25 I squared. But hold it, look right here please students. I squared always equals -1, so where the I squared is, I put a -1. So 375 parentheses -1, and 375 times -1 is -375. 375. All right, let's move on to the next term. One, we're putting a 1 in for a. 1 to the 3rd power is 1, and 1 times 20 is 20. So I just have 20, and then I would have 5i to the 3rd power. Now let's think about this. 5 times 5 times 5 is 125. So I would have 20 times 125 I cubed. 5 times 5 times 5 is 125. I times I times I is I cubed. Now for I cubed, don't forget what you can write. For I cubed, you could really write I squared I, because I squared I is I cubed. Why would I do that? Because now for my I squared, I can put a -1. So now inside this parentheses, I have 125 times -1 times I. That's a -125 I, and then 20 times 125 is going to be 2,500, negative, because positive times negative, so negative 2,500 I. All right. Not too hard, just tedious like a lot of these problems are, but not super difficult, I wouldn't think. Okay, we're dealing with 15 now. Of course, a squared is 1 squared and 1 squared is 1 times 15 is just 15. I'm going to start working over here so we have a little more room. So I would have 15 times b to the fourth. Well, that would be 5i to the fourth power. Now, 5 times 5 times 5 times 5, I believe, is 625. Yes, 625. So 5 times 5 times 5 times 5 is 625. I times I times I times I is I to the fourth. Now, for I to the fourth, we're going to write this. See if this makes sense. For I to the fourth, we're going to write I squared. I squared. You're always trying to break your i's down into groups of 2 or sets of 2 so that you can then substitute -1 in for those I squareds. So what we have now really is 15 times 625 times a -1 times a -1. Okay, that's really all that you have. So if you take 15 times 625, you will get 9,375. Times a -1 makes it negative, times a -1 makes it positive. So your final answer would simply be positive 9,375. And the good news is we only have 2 terms left and we're finally finished, okay? And I do apologize again for saying that we were finished and forgetting that we had one more problem to do, but we're almost finished. Okay, a to the 1 power, put a 1 in for a, 1 to the 1 power is 1, and 1 times 6 is 6. Now we have 5i to the 5th power. Now that would be 5 times 5 times 5 times 5 times 5. And that would give you 3,125. And then I times I times I times I times I is I to the 5th. But of course, for I to the 5th, what we really want to put is break it down in sets of 2. I squared times I squared times I. So really, finally, what we have is 6 times 3,125 times a -1 times a -1 times I, because your I squareds do equal -1. So 3,125 times 6 will give you 18,750. I'm going to write that right down here, 18,750. And of course an I on the end because of this I right here. But let's make sure our sign is correct, okay? Positive times a positive is positive, times a negative is negative, times a negative is positive, okay? Let's move on now to finally our last term, finally, and let's see if we can't finish this problem up, okay? Actually, do we have 2 terms left? Let's see. 1, 2, 3, 4, 5, 6, 7. Yes, this will be our last term. So finally, we're finished. B to the 6th. Well, for B, I'm going to substitute 5i, and we'll raise that to the 6th power. So 5 times 5 times 5 times 5 times 5 times 5 is going to give you 15,625. And then I times I times I times I times I times I will be I to the 6th. Now for I to the 6th, you can break that down to I squared, I squared, I squared. And so really basically what you have is 15,625 times -1 times -1 times -1. Okay? And of course, that's going to end up giving you a negative number because a positive times a negative is negative, negative times a negative is positive, and positive times a negative is negative. And 15,625 times 1 times 1 times 1 is 15,625. These are really long. I will give you some of these on your test, but I won't make them that long because my goal is to make sure you know how to expand. I'll probably do that with a really easy problem like a plus b or x plus y. Then I'll give you one like this, probably not as high of a power, and then maybe a couple more. But when it comes to totally expanding these out, I will be very reasonable on your test. Okay, number 42. Number 42. Now, thankfully, we're not going to expand this entire binomial. We're just going to find the 4th term. Now, students, you do understand we could use Pascal's Triangle, but we would have to go out. I mean, here's what we have already, and we have how many terms? 8. We want to go to 13 because we have a power of 12, so we want a row that has 13 terms. We'd have to add 5 more rows. That's going to be big numbers, and it's also going to be really long. There's no need for that. I taught you a quick way to find a certain coefficient of a certain given term, and I taught you to do this. I taught you that whatever your power is right here that you're expanding the binomial to, you put that number right here. So we can do that quickly. Okay? Now for the bottom number that you're going to put here, you always take one less than the term you're looking for. So we're looking for the fourth term. 4 minus 1 is 3, so we put a 3 here. And this expression right here will give you your coefficient. Remember what this expression means? It means you have a set of 12 and you're pulling out of it combinations of 3. And how we solve that would say we have a set of 12 and we're finding how many permutations of 3 would come out of that, and whatever this number is right here, your 3, you put it down here, factorial. So now up top we're going to write 3 blanks because of this 3 right here, 1, 2, 3, and we're going to start at 12 and go down, 12 times 11 times 10. And the denominator is going to be 3 times 2 times 1. Now I can cross off the 3, put a 4 right here, cross off the 2, put a 5 right here, and we end up with 44, 220 over 1. So we just found the coefficient, 220, and now we know we're going to go to the fourth term, right? The fourth term. So let's go ahead and be careful here. For the fourth term, I know my first term is going to be a to the 12th power. That's my first term. And I know my second term is going to be my second term will be a to the 11th. My third term will be a to the 10th, and my fourth term will be a to the 9th. So 220, a to the 9th. Now hold it. Notice I have an a here and an x here, so it would be x, and then I know my x has to be a 3. How did I know that? Because these two numbers here have to always add up to this number right here, always. So that's it. That's it. Look it over, rewind it, and watch it again if you need to. That's the fourth term. If you were to expand this all the way out, this would be your fourth term. All right, number 43. Now this one's going to be a little more difficult, and I know it's hard to see. Let me glance at my book here and see if I can't rewrite this. It's 2a minus b to the 18th power. All right, 18th power. That's crazy. There's no way we're going to use Pascal's triangle. Now, first of all, do you understand I'm going to say that a equals 2a and b equals a negative b. So now I can rewrite the problem like this. A plus b to the what power? 18th, and I'm going to find the what term? 12th term. Now, let's find the coefficient. Put our parentheses. This number here, 18, goes right here. I'm finding the 12th term. You always subtract 1 from it. That'd be 11. So we rewrite this like this. We have a set of 18, and we want to see how many combinations of 11 we can pull out. That would be the same thing as saying we have a set of 18, and how many permutations of 11 can we get out? All over 11 factorial. This will require a little bit of work, which is fine. We have our calculators, but you would go 18 all the way down to 8. So 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8. Now that should be 11 numbers going across the top. How did I know to put 11? Because of this number right here. Excuse me, sorry. So let's make sure I'm right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Very good. In the bottom I have 11 factorial. I'm going to put 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and then a 1. Now let's do some quick canceling. It will make the problem easier, trust me. So 11, 10, 9, and 8 can cancel with 11, 10, 9, and 8. 7 would go into 14. 2 times. 6 would go into 18 3 times. My next number is 5. 5 would go into 15 3 times. 3 would go into 12. Actually, 4 is next. 4 would go into 12 3 times. My 3 would go into, I guess, a 3, so we'll call that a 1. And my 2 would go into 16 8 times. Now be really careful here. I have all ones in the denominator. I'm going to circle what I'm multiplying. Now to you, you might not like doing what I just did. I do, because it makes the numbers smaller to type into your calculator, and this is a 1, so we don't need that, and all of these are gone. So really all that I'm going to type in is just 3 times 17 times 8 times 3 times 2 times 13. And if you do that correctly, and I'm checking my work here, hopefully I'm not making a mistake, you get 31,824. So 31,824. Now if I made a mistake, I apologize. I will glance in the book here and check my answer at the end, but I do hope that is correct. Now let me go ahead and erase all of this so it's out of the way. We found the coefficient, and that was the main thing that we wanted to do, and there's our coefficient right here. Now let's go ahead and work with our variables. So it looks like I'm going to the 12th term. Now think about this. You know your first term would be a to the 18th. You know your second term would be a to the 17th, right? You know your third term would be a to the 16th. You see the pattern? Whenever you add the term and the exponent, it equals 19. So if I'm looking for the 12th term, then I must have a to the 7th, because 12 plus 7 is 19. So I know I have a to the 7th, and then b. Now what does this exponent right here have to be? Well, don't these two exponents always have to add up to whatever your original power is, or whatever you're expanding the binomial to? The answer is yes. And so because I have an 18 here, then I must have an 11 here. There. Now unfortunately I've still got to make my substitution, so it's not going to be pretty, but it's what I have to do. So now I have 31,824 parentheses, and then 2a for a to the 7th power, and then for b I would have negative b to the 11th power. Now please watch this carefully. First of all, I can bring down my 31,824, okay? And then I have 2 to the 7th power, 2 times 2 times 2 times 2 times 2 times 2 times 2. And that's going to be 128. And then a times a times a times a times a times a times a will be a to the 7th. And now be careful with your negative b. You have negative b times negative b times negative b times 11 times. Well, if you have 11 negative signs, it's an odd number. Negative b times negative b times negative b times negative b. That's going to end up being a negative b to the 11th power. Okay, so now I have a positive 31,824 times a positive 128 times a negative 1. So let me type that into my calculator very quickly. And you will come up with negative 4,073,472 a to the 7th power b to the 11th power. I was really hesitating to check this in the back of the book, worried that we made a mistake somewhere, but it looks like we did not. It matched the answer in the back of the book. So we're looking pretty good here, and hope this has been a little bit of a help. I know they're a pain, but these are good to help you understand how to expand binomials. Now let's see where we're at here in our assignment. I might have the wrong one open. Let's see. No, I do not. Good. Okay, we're going to page 889. We're looking at 1, 3, 7, and 13, and I don't think we'll find those very difficult at all. All right, so let's continue on. Okay, that's all they want you to do is simply find permutations of 6 that come out of a set of 6, and so that just simply means this. This number right here tells you how many objects you have. So here's your 6 objects. I'm going to use X as 1, 2, 3, 4, 5, 6, and this second number here tells you how many blanks to put. So for your first blank you have 6 options. When you put 1 here, now you have 5 options left. When you put one of your objects here, you have 4 left, then 3, then 2, and then 1. So 6 factorial would be 720. 720. Okay, not too bad. Pretty simple. Make sure you know what the notation means. Make sure you know what each one of these numbers is telling you to do. All right, let's take a look at number 3. Same thing. This number here means you have 10 objects and you're finding how many permutations of 7 you can take out of those 10 objects. I'm going to put 7 blanks, and then I start with the number 10. I have 10 options. Now I put one here. I have 9 options. I put one here. I have 8 left, then 7, then 6, then 5, and then 4. So it's 10 times 9 times 8 times 7 times 6 times 5 times 4. And if you do that correctly, you will get 604,800. 604,800. All right, number 7. 0 factorial and 1 factorial always equal 1. Period. No work to be shown. That's mathematically understood, and you need to know that because there are some formulas we use in which we have 0 factorial. 0 factorial will always equal 1. Moving on to number 13. Okay, up top we have 10 factorial, so 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. By the way, you're welcome to use calculators on these if you want to. I have no problem with that. I'm just going to break them down like this. 7, 6, 5, 4, 3, 2, 1, and then 3, 2, and 1. Okay, look at this. 7, 6, 5, 4, 3, 2, 1. 7, 6, 5, 4, 3, 2, 1. Look at that. Cross off your 3, cross off your 9, and put a 3. Cross off your 2. Make this a 5, and that's it. 5 times 3 times 8 times 7, so not too bad. I can do that pretty quickly. 5 times 3 times 8 times 7 would give me 840. All right, so for number 13, actually, is that right? Let's see if that's right. Five times 3 times 8, because this 7 was crossed off. I apologize. 5 times 3 times 8 would give you 120, and that is the answer, 120. Moving on to number 1, and in case you can't read that, that is, you have a set of 13, and they want to know how many combinations or sets of 2 that you can pull out of that. Okay, and we have done quite a few of these, a little redundant. The reason I want to put some of these on your test is to make sure you're familiar with the notation here, and it simply means you make it a permutation problem, whatever this number right here is. You put that down here, 2 factorial, and this number right here tells you how many blanks you're going to have up top, and you start with 13 and go downwards, so 13 times 12. In the bottom is 2 factorial, 2 times 1. Cross off your 2, make it a 1. Cross off the 12, make it a 6, and you will end up with 78. 13 times 6 is 78 over 1. Okay, the next number is number 3. Exact same problem again, only a different notation. We have a 13 right here. Of course, what that means is combinations of 11 taken out of a group of 13, which is the same thing as saying you want to find out how many permutations of 11 can be taken out of a group of 13 over 11 factorial. And let's see, you would go from 13 all the way down to 3. So 13 times 12 times 11 times 10 times 9, 8, 7, 6, 5, 4, all the way down to 3. Okay? And then that would be over 11 factorial. So 11, you would have 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So you really could cross off your 11, 10, 9, 8, 7, 6, 5, 4, 3. Okay, you could cross off down here your 11 all the way to your 3, and you're left with 2 over 1. Cross off your 2, make this a 6, and you also get 78 for number 13. Now, if you didn't understand all that simplifying that I said you could do, you could always just type the whole thing into your calculator. There's no problem with that, okay? That's totally fine. And I think that's it. So that's been a pretty tough review sheet, pretty long, but I told you guys that's how it's normally going to be. That's it on the review sheet. Call or email if you have any questions.